So Unit 3, Lesson 5, so converting from general form to standard form by completing the square. So we're going to go from our, this is very, very important in terms of this unit. If you can do this very well, you're not going to have any issues. Okay? You're going to go from this, and you're going to make it look like this. And to do that, you need to complete the square. Okay? Now, completing the square is what I'm going to teach you today. The reason we have to complete the square is this. This guy right here, that's a what? It's a perfect square. If you FOIL that out, that's a perfect square binomial. Okay? So what do I mean by perfect square? Well, I mean x plus 2 squared, right? That's a perfect square binomial. That's the same thing as x plus 2 times x plus 2. That's the kind of things we're looking for. Okay? Because those are in our standard form. Okay? All right, so let's go ahead and practice completing the square first. All right, so complete the square. Those are examples. Expand the following perfect squares. Okay. All right, so we're expanding the following perfect squares. So we have x squared. That's just for practice. 4x. 4x is 8x. 4 times 4, 16. Okay, we're going to develop the pattern. You're going to see it. Okay, then we're going to have the x plus 7, x squared plus 14x plus 49. Okay, x squared minus 10x plus 25. X squared minus 2x plus 1. Okay, and then it wants you to put out, like, what is it in terms of the pattern? Okay, what is it in terms of the pattern? Oops, this is the wrong one. So how could you write a general pattern there? Well, what do you notice? What's, if this is A, what's the last number in respect to A? A squared, good. So we know we're always going to have a squared out here, and since that's a plus, it's always going to be a plus, right? Because anytime you square something, it's going to be a positive. Okay, so let's just do that for both sides. So what I'm saying is, I know that some of you guys don't like the letters. It's just saying if you have anything perfect, like a perfect square binomial, the last piece is always going to be that number squared. Okay, and it's always a plus because it's an a squared. So I'm going to do that for both of them here. Okay, now for the middle, what's the pattern for the middle? Good, yeah. So it's 2 times 4 times x. 2 times 4 is 8, and x will be x. 2 times 7 times x, 14x. 2 times negative 1, negative 2x. So yes, it's 2 times x times a. Or 2ax, however you want to write it. And this is the only thing different on this one, it's minus 2xa. Okay, and then the front, that's the easy one. That's always just going to be x squared. Okay, so that's just the pattern of the perfect squares. It's important to know that, so when we're building is we're completing the square, we're kind of cheating essentially. We're trying to make it a perfect square. So we're going to be looking for this type of pattern. Okay, all right, so factor the following expression into perfect square. So we're going backwards now. So then, what's the square root of 9? 3. What's 3 times 2? So this is a perfect square, right? Okay, so it's going to be x plus 3. Is that too quick, or are we on the same page? Good? Okay, so then, Adam, what's the square root of 36? 6, right? And then 6 times 2 is 12. So this one's going to be x plus 6. Good? Okay, and then we'll just keep going around. Lauren, what's this one here? Square root of 4 is 2, and times negative 2, right? So it'd be a negative 2. Okay, good. Sam? Okay, good man. Square root of 64 is 8. It's 8 times 2 is 16, but it's negative, so we want x minus 8. Good? Okay. Now we're going to start the process of completing the square. Sorry if you didn't get that. I'll slow down a little bit here. All right, so C. This is the main concept you're going to want to get. It says add an appropriate constant so the following will be a perfect square. Okay? So what it wants us to do is put here what makes it a perfect square. So with that in mind, what is the first thing that you want to figure out? Or maybe what's the first thing you're going to do mathematically so that you know what will go on the end? Divide. Exactly. Divide the middle by 2. So what's 2 divided by 2? 1. What's 1 squared? That's what goes right there. So divide the middle by 2 and square it. Okay, good. And so that will be x plus 1 squared. All right. Eli, what do you think for the second one on top there? What would that one be? Good, because 18 divided by 2 is 9. 9 squared is 81. So x plus 9 squared. Good. Oh, Kyle, you want to try the negative 3 there? A little bit trickier. No? Well, what do we want to do to the negative 3? No, we want to divide by 2 first. See what I'm saying? And right, and that's what makes it weird is we have a fraction. And you have to square that. So how do you square fractions? Top and bottom. So it's going to be 9 over 4. Okay? But see how this thing's always squared? That's what's going to be in here. Like that. That's kind of an important concept. The thing that we're squaring is the thing that's going to go for your A. The thing that we're squaring is your A. Okay, let's pause for a second. Any questions yet? Quinn, you want to take a shot at the 1/4? Well, let's see. Okay, so can you tell me what you did first? Just tell me. So what is 1/4 divided by 2? That's right, which is 1/8, correct? Because half of a fourth is an 8. Okay, so you have 1/8, and it's a negative. You squared 1/8. 1 squared is 1, 8 squared is 64. So you are correct. This right here is your A. Whoops. Do it like that. X minus 1/8. Okay, so the process of adding a constant term to a quadratic expression to make a perfect square is called completing the square. So we're going to be doing this to complete the square. Okay, so to complete the square, we have to make sure that we want to get in the form of this. Okay, what they're talking about with B is they're talking about the second term, A, B, and C. So it's half of B squared. That's what this is all saying here. Half of B squared is our last term. Okay. Okay. So I think we're setting it up. If you're still a little fuzzy, hopefully when we get to the examples here, that'll help. Okay, so here is the first, just kind of your steps to doing it, which I do think the book does a good job. I do think the book does a good job of providing steps for those of you that get stuck. And unfortunately, I know there's probably only 2 or 3 of you who actually look at this, but really look at the steps. They help you get through the problem. Okay, so first thing, take half of the numerical coefficient of the x term and square it. So that's the x term is your b, or the middle. You take half of it. Add and subtract the square number in step 1. We'll tell you what that means. And then form a perfect square and write it in factored form. What this is, if you want to write on this right here, step 2, is balancing the equation. And you'll see what I'm talking about when we get to the example. Because we can't just add numbers out of nowhere, right? Whatever you do to one side of the equation, you have to do to the other. That's the golden rule of algebra, if you ever heard of that before. Anything you do to the left, you have to do the right. And we can do anything we want, as long as we do the same. All right, so let's see here. Express x squared plus 10x in completed square form. Okay, There's a couple of ways to go about this, okay? What I like to do, and this is me, I will show you both ways and we'll do a class vote. I like letting you guys have decisions. So there's two ways you can look at this. You can go, I like to make the y 0, okay? And the other way is you can keep y. Okay? All right, so just let's focus on the left one. So what I'm going to do is what's half of 10? What's 5 squared? So it's not 16, correct? I want to get rid of 16, so I'm going to throw it to the other side of the equation. And I put a box here to let me myself know I'm completing the square. Okay? And this is what I do. We just did it. Half of 10 is 5. 5 squared is 25. So I added a 25. Part 2 on your steps. Oh, okay. Sorry. Part 2 on your steps, we have to balance. If I add 25 here, I need to add it here. Okay? Are we okay with that? That's the main thing with completing the square. Okay? Okay, so I put plus 25 here, so I'm going to put it here too. Okay, this 25 minus 16, because plus and minus is minus, is 9. X squared, this, what does this shrink down to? What's it make? Makes a perfect square of x plus 5 squared. This is the part that people get confused on, like how did this turn into this? Well, we factored it, right? It's x plus 5 squared. If you FOIL that out, you'll get above what I have. Okay, and then now look. I'll bring the y back after this. We are in standard form. We went from general to standard. Okay. All right, I'll show you the other side, and then we'll do our vote. So really give this one a chance. If you like that one already, don't tune out the second one. Maybe you like the second one better. The second's a little bit more what the book does. They just don't move it over. To me, it makes it messy, but again, I'm not going to try to sway your vote. Okay, so this one here again, we knew this was a perfect square, so I just kind of push it out. I know I need to get a complete the square, so we still do the same thing. I'm going to go 5 squared is 25. Since I added 25 here, I'm going to minus 25 out here, just to the same side. So I'm doing a plus 25 and a minus 25, which is 0, so nothing's happening. Okay, and so then it shrinks down again. This shrinks down. This becomes, so we have the same thing. Okay? The only reason that I even do this one is because it kind of helps me focus on this part instead of the stuff on the outside. Yep.
Wait, how does 25 plus 16 minus 25?
How does say that again?
So wait, so you're adding 25 plus 16 minus 25? Is that what you're saying?
Well, this I factored.
Oh, if you just break it up.
Yeah.
Okay.
Yeah, I factor this guy down. I keep that 25 in here. Yeah, I see what you're saying.
Okay.
Yep. All right, so we'll say this one's number 1. Well, number 2. Whichever one you vote, so I'm going to do the examples the rest of the time. Okay? So who wants 1? 3, 4, 5? Who wants 2? 1, 2, 3, 4, 5, 6, 7. All right, number 2. All right, we'll say it's 2. If it makes you feel any better, I think when you do, if you look at the notes filled out on Moodle, they're like this. Okay, so it's fine. Okay, so let's go to number 2. And those of you who got outvoted, it's not that big of a difference. You could still do the other way. All right, function f is defined. X squared minus 9x minus 20. Determine the minimum value of f by writing the function in standard form. So what's the minimum? Let's go back. This is combining the last 3 sections. We know the minimum is what value? It's a value, I don't want to give it away, but yeah, it's the value of the vertex, great. So it's the vertex is, remember the vertex is P and Q. Which one's the minimum? Which one affects the height of the parabola? The y, or which one's the y value? Q. We're trying to find Q. Okay, that's all we're trying to do. And when we're in standard form, we like standard form because the Q is right in front of us to see. Right? So that's what we're going for. So, here we go. So I'm going to go the way you guys asked. Okay, 9, half of 9. Okay, so it's going to be kind of messy. It's going to be a fraction. That's okay. We can still do it. But I do know that half of 9 squared is not 20, correct? So I do know I need to move that out. So I'm going to go y equals x squared minus 9x. I like to put plus box, let myself know I'm completing the square, and then my minus 20 is out here. Okay, half of 9 squared. So I'm going to go negative 9 halves squared is going to go here. That's 81 over 4. 9 squared, 2 squared. So this is 81 over 4. So I have to go plus 81 over 4. Okay, because that's, oh, nope, I lied, minus 81 over 4. I have to level it out. My bad. Minus 81 over 4. Say that one more time, Eli. Right, and then every time we square something, it's always going to be a positive, so that thing you put on the outside is always going to be the negative of it. Yeah, but you'll never get negative 81 over 4 because we're squaring. So it'll always be minus. Does that make sense? Okay. All right, so now we can shrink this down. Okay, you don't have to sit here and try to factor it. It's right here. X minus 9 halves squared. That's what it is. So it's x minus 9 halves squared is your factor. And then the only thing I have to do is I have to do this. Okay, you can use your calculator if you want. Let's practice using our fractions here. What is 20? Everybody never gets when I say this. What's 20 in terms of force? What is 20 in terms of force? Huh? 80. Good, Zach. So 80 force is 20. What that means is 80 over 4 is equivalent to 20. Because 80 divided by 4, that's why I'm trying to say it. Because I want them to be in force, right? 80 minus 81 is negative 161. Okay, what's my Q? It's right there for us to see. Say that again? No, that's my P. My P is 9 halves. Negative 161 over 4 is your minimum. Okay? 9 halves would be your P, though. Okay? All right, so just one last thing. Make the connection. Vertex of this would be 9 halves because it's opposite what we see, and then negative 161 over 4. All right, just got a couple more here. Everybody good on writing almost? Okay. Okay, so from general form to standard form. So use the coefficient of x squared as a common factor. Now, we are going to do some that a is not just 1. And it's going to make us have one other thing to just account for, okay? So follow the rules here. So use the coefficient of x squared as a common factor for the x squared term. Take half to get to the same step. Take half, add and subtract to both sides. Multiply the term which has been subtracted, okay, in step 3 by the coefficient of x squared. So step 4, step 1 are related. And what that's talking about is if I have a 2x squared in front, on that last problem, what do we add and subtract to both sides? Excuse me. 81 over 4, right? Okay. If there was a 2x squared there, I'd have to times that by 2 and put it out. Okay, I'll show you. I'm kind of doing it out loud here. Get you to think about it, but we're going to do it. Okay? So that's what this is telling you to do. And then 5, make your perfect square and simplify. Okay, so let me get to the actual example, which you'll probably enjoy better than me talking. Okay, so see this number 3? You got a 3x squared there. Okay, So what we're going to do is, okay, we're just going to push this 20 out, and we have it out here. I still can GCF. Okay, I'm still going to GCF right there. Okay, so I'm going to pull a 3 out. Not a 3x. We need the x to stay. Just a 3. So it's going to be 3 times x squared minus 6x plus box with a parentheses. And I'll show you why I have the parentheses there. Okay? Is everybody okay with that step so far? All they did was I GCF. Yes, Zach? The 20's outside the bracket because the 20's not going to be part of my perfect square. Just like we moved the other stuff, like the 80 out and all that stuff, we're going to move the constant, we're always going to kind of push outside. Okay? Okay, so now, what is half of negative 6? It's negative 3. We're doing our perfect square thing. Square it, 9. Okay, so just normal. We just did complete the square, half the middle, and squared it. Okay, now here's the new thing, and I'll wait till everybody's looking up so that you're with me. Okay, normally we would add 9 to both sides, or I'd put minus 9 over here, right? This is what you have to do first. You have to go 9 times what's sitting outside, and then put it over here, which would be minus 27. That's the only curveball. Questions on that? That's as hard as it's going to get. We're not going to get any harder than that, unless you're going to have fraction stuff. But okay, so what happens is this shrinks down. Now you're going to see what this does. It's going to look like a standard form equation. The 3x minus 3 squared. Okay, the 3 is my a. What does that stand for? What's a stand for? 2 lessons ago, vertical stretch. And this is a expansion or compression? Expansion, very good. Okay, so now I'm going to go 20 minus 27, negative 7. It's the standard form. There it is. You have something to say, Sam? No? I thought you were about to say something. Okay, all right. So, okay, so all my information, why this helps us, when you look at this, you cannot figure out all the information. You got a question, Ty? Why is the 3 still there? Because it's my A. It's my stretch, like I can't get rid of the 3. 3 has to be there. Because remember, your standard form equation, its form is A times x minus p squared plus q. So an A is okay to be there. Okay? So why we like this is I can get all this information now that I couldn't get from here. Here's everything I have. My vertex is what? 3, negative 7. Good. My axis of symmetry is what? 3. It's always the x value. Is this a max or a min? Min, because the problem is going up. It's a min at 7. Good. So you guys seeing all this now? It's all coming together. Min at 7. Okay, and the last thing, I have a vertical compression, or excuse me, expansion of 3. No flip, no reflection, because no negative. Okay, that's why standard form helps us. It gives us everything about the graph we need to know. Okay, all right, we got 2 more. All right. Okay, so this one says convert to standard form by completing the square. So the first thing, what bugs you about example 4? Yeah, they're all mixed up in the wrong places. So yeah, I'm just going to move it to negative 2x squared to positive 10x. I'm going to go ahead and skip and put plus the box. I'm going to put the 7 out here because I know 7 is not a perfect square. Okay, and I'm right back to my normal game. What am I going to do next? What do you think? James, what would you do with these 2 here? Close. By what kind of 2? Negative 2. Did you say negative 2? Okay. Okay, negative 2. I have x squared now and a minus 5x. Plus box. The plus the 7 still outside. It's all right. You're thinking. I like it. Okay, so this is going to not be as fun. We're going to have a fraction. Okay, negative 5 and a half is just negative 5 halves. I'm going to square that. It's going to give me 25 force. Again, I need to times it here. Okay, and that's going to make me what? What's a positive times a negative? And I'm supposed to subtract it, so it makes it what? Makes it positive. Okay, if you want to write it, we can write minus, and then we can minus 50 over 4, like that, which minus a minus is a plus. So that's the time, like back to what Eva was saying, that's when you'll actually add if you're timesing by a negative coming out. Okay, so let's get 7 in terms of force. Okay, well, first off, let's shrink this down. X minus 5/2 squared. That's my first chunk. Now say simplify the end. 7 in terms of force is 28 force plus 50 over 4 gives me 78 over 4. And that reduces to 39 halves. So there's your standard form equation. Again, my vertex is 5/2, 39 halves. Okay. Is there a question? We good? Good. Anything? Yeah, James? Yeah, 78 over 4. I crossed my 7s. 39. Half of 78 is 39. Yeah. Good? I know handwriting is my number one flaw. Okay. All right, last one. We're good. Okay. Well, at least that's the one I think it is. If I have other flaws, don't tell me. Don't ruin my confidence. Okay. All right. So in completed square form, use this form to determine the zeros of the function. Okay, so we're going to determine the zeros of the function. So we want to figure out where the zeros are by solving. Okay, so we're going to get it in standard form, and then we're going to do what we did last class. For those of you who are here, we're going to plug in 0 for y and solve. Okay, so here we go. All right, so y equals 3x squared minus 12x plus the box, signifying I'm doing completing the square, and minus the 8 stays out here. Okay, we're going to pull a 3 out. 3x squared minus 4x plus the box minus the 8. Okay, and then what do I do next? Tom, what do I do next? Here, sorry. What's that? Yeah. What's half of it? Okay, what's half of it? And then what do you do with that? After you got to square, because you got to complete the square, okay? So we put it here. Good. So 4 goes there. And then I have 3 times 4 is 12, so minus 12. I shrink this down to 3x minus 2 squared, like that. Negative 8 minus 12 is negative 20. That's what our standard form equation is. Okay. Now it says it wants us to find the zeros of the function. Okay, so that means we want to solve for x. So we want y to be 0. So we're going to go 0 equals 3 times x minus 2 squared minus 20. And we're going to solve. It's going to be ugly, but that's okay. We're going to add 20. We're going to trust our math. Divide by 3. Square root. Okay, and then we're going to add 2. Remember, when you add 2, it makes it a plus or minus the square root. So it's going to be 2 plus or minus root 20 over 3 is x. It's really ugly, but you just put in your calculator and you're going to get 2 decimals. Okay, your decimals will be x equals negative 0.58, and x will be 4.58. Those are your two functions. There's not functions, your answers, excuse me. Okay. Yeah, so right here. So then I square rooted to get rid of the square. Is that what you're talking about?
Yeah, so that would be plus minus square root.
Right, plus or minus square root 20 root 3.
Yeah, gives me x minus 2, right?
Yep. Yeah. And then you add the 2 to put in front of it, so your 2's in front now. Okay. So again, just sort of making the connection, what we just solved for is where this parabola, that's still a parabola, crosses the x-axis. At these points where it crosses the x-axis. Okay, now I want you to do something. What is my vertex here? What is my vertex? Positive 2, negative 20. Okay? Now what I want you to do is, what is 4.58 plus a negative 0.58? Come on. 4. What is 4 divided by 2? What was I just doing? What do we know about parabolas? We know that our parabola, so this parabola here is a positive. So let me just kind of show you my illustration, what I'm talking about here. And we know, we'll say this is 2, negative 20. What I was trying to do was, I know parabolas are symmetric. So if they're symmetric, the vertex has to be these added up divided by 2. Okay, so here's my vertex. How far is, like, put in your calculator right now. Well, we don't have to do that. How far is negative 0.58 from 2? Like, how far this direction? Say it? No, say it. You're right. Oh, you did? Oh, sorry, I thought that was it. 4.5, not quite. 2.58, right? So if we're at 2, and I'm going to negative 0.58, it's a 2 plus the 5/8, right? And then if I'm here at 2, how far is it to 4.58? 2.58 that direction. Okay, what I'm showing you is it's symmetric. Okay, so for those points are going to be symmetric. They're going to be the same distance from the vertex. They're going to be the same distance from the vertex. That's all I'm trying to show you. Okay? All right. Make the connections. All right, that's it for